Okay, this is college algebra, and this is review 5, and it starts on page 30, and is a little bit longer than some of the other lessons, but we'll see if we can get through it pretty quick. Again, we are still reviewing for the class. So let's look at the top of page 31. It says the domain of a rational expression. The domain of an algebraic expression is a set of all real numbers for which the expression is defined. So basically, when I have something like 2 over x minus 3, the domain is all possible answers that make this a true and doable expression. So, for example, every number in the whole history of the universe works for x here except 3. Because if we put a 3 in here, we get 0 in the denominator. Whenever 0 is in the denominator, it's undefined. There's no answer. So all numbers will work for that except 3. So the answer you would put would be the set of all real numbers, and then maybe you just write except the number 3. Okay, and you'd have the right answer there. Now, there are some correct mathematical symbols to use to write that, but right now I'm just trying to get you to understand that there are some numbers that won't work. Now, if you look at part B of example 1, they have x squared minus 4, and they also have x squared minus 4x minus 5. Okay, so first of all, really, you're not too terribly concerned about the numerator. You're mostly concerned about the denominator. So if you factor that, let's just go ahead and factor the numerator. Whoops. It's a difference of 2 squares. Okay, so we're not asked to find the answer, just to tell what the, the domain is. So we've got x there and x there, and an x plus 1, and an x minus 5. So what we're looking at is what numbers are going to make the denominator 0. So x is negative 1, and x is 5. So those are the two numbers that will not work. So the answer is the set of all real numbers such that x is not equal to negative 1 and x is not equal to 5. Okay, so I was talking about symbols for this. Let's go ahead and write the symbol for the answer for this one right here. And this is what it looks like. Let's do it here in red. The set of all numbers, set of all x, such that x is a real number and I usually am fine with that, and x is not equal to negative 1 and negative 5. Okay? So that's the symbolism for writing it. It can be any real number except negative 1, oops, that's not a negative 5, and regular 5. Okay, so x is negative, it cannot be negative 1, and it cannot be 5. Okay, so continuing on here, let's jump over to page 32, and we've got an example, and they're asking you just to simplify. Now remember, when they're asking you to simplify, they're not asking you to find the answer. All they're asking you to do is make it easier to read. Okay, so let's get rid of some of this here. So we've got 9x squared plus 6x minus 3 over 12x squared minus 12. So because there's no equal sign, we're not finding x. We're just simplifying this. So we're going to look at the top, and we're going to factor out a 3, and that leaves us with 3x squared plus 2x minus 1. And in the bottom, we're going to factor out a 12, and it's going to leave us x squared minus 1. Okay? So we can keep going. We can take this top here and factor that down. We can look at the x squared minus 1 and realize that's the difference of 2 squares. So let's go ahead and factor that down. We'll do that here in green. So 3 times, and we're going to break that up into two quantities. And when you do the math, you'll get that and that for the top and the bottom. We're going to leave that as 12, and we're going to put that as x minus 1 and x plus 1. And then that gives us a chance to cancel that with that. And we have 3 over 12, so we'll cancel that and cancel that, leaving us with 3x minus 1 over 4 times x minus 1. Alright, so that is the simplified version of that once we factor, and the only reason we factor is so that we can cancel. Okay, let's look at this one. This is example 3, part B. And the reason I'm going to look at this one is just because of the 2 minus x here. Because usually you're used to seeing x minus 2, and because it's written that way, it's going to cause you some struggle here, so it might be good to go over this. So what we're going to do, first of all, is we know that when we factor the bottom, we're going to get x's as the first term and a number as the second term. We're going to get x plus 3 and x minus 2. Well, if we look at this, it's like it's 2 minus x, so it's very similar to what we have here. So if we can switch this around to x minus 2, then it'll be able to cancel with that. So how do we switch that around? It's quite easily done by factoring out a negative 1. And that gives us negative 2 plus x. Because if we add this negative 1 back in, negative 1 times negative 2 is positive 2. Negative 1 times x is negative x. So this is the same thing as this. But notice, I now have negative 2 plus x, which means I can switch that around to x minus 2. So let me erase what I have there, if I can, if it'll let me. It's not going to let me erase that. Okay, let's do it another way. So this is going to be negative 1 times x minus 2. And that allows me to cancel that and cancel that and give me negative 1 over x plus 3, or what I really prefer having you do is write it like that instead of putting the negative 1 up there. I mean, either one is right. This one here is just a little bit more acceptable. All right, so let's continue on. Let's go to example 4 on page 33. So this one shouldn't be too hard because all we're going to do is simplify and see if we can cancel. The left-hand side is already simplified, so we're just going to rewrite that the way it is. And this is the difference of two squares, so we can write that way. And the bottom is a trinomial that we're going to factor into two binomials. So my question is always, what times what is negative 2? Added together give you negative 1. And in this case, it's going to be x minus 2 and x plus 1. Alright, so that allows me to cancel, and I'll do this in red, that, I'm sorry, the wrong one there. It should be this one and this one, leaving me with x plus 4 and x plus 3 on top, x minus 2 and x plus 1 on the bottom. And that's all you're going to do. Don't multiply those because you're supposed to simplify, and that's as simple as you're going to get. And remember, when you're dividing, if this were a division sign up here, you would take these two here and you'd flip it over and then do the same thing. Okay, adding and subtracting rational expressions, bottom of page 33. This one, example number 5, let me write it up here. So for this kind of problem, what we're going to end up doing is we're going to factor it down first, And then we're going to find common denominators. Because of this addition sign right here, we can't combine these like we could in the other stuff when we were multiplying and dividing. We're going to have to find common denominators. So before we define common denominators, we end up having to simplify. And actually, what I would suggest doing first of all is just simplify the denominator. I mean, you can simplify x squared minus 4x plus 4, but it's going to be a waste of time because when you're trying to find common denominators, it's going to change your numerator and it'll be completely different anyway. So don't even worry about the numerators. Just factor down the denominators. So when we factor those down, we're going to get on top x squared minus 4x plus 4. In the denominator here, we'll get 2x minus 1. And I'm assuming that you can still group and do this as far as finding the two terms multiplied together to give you this right there. And then the second part is not going to change a whole lot. We're just going to factor a 2 out. And that looks like that. Okay, so now I go and say, all right, so in this expression here, what do I have over here that I'm missing over here? And in this case, it's a 2. So I'm going to multiply top and bottom of this by 2. So let's just do that, put that in red here, 2 and 2. Okay, now let's look over at the right-hand side. What am I missing here that I have over here? And in this case, I have a 2 there and a 2 there. I have an x minus 1. So I'm missing a 2x minus 1. So I'm going to do that in red. So top and bottom. Okay? So since I did all that, now I'm at a point where I can continue on here. So multiplying this whole thing, I end up getting 2x squared minus 8x plus 8 over my 2 times 2x minus 1 times x minus 1 plus, and I'm going to use the FOIL method for my x plus 4 times 2x minus 1, and I get 2x squared plus 7x minus 4, and I guess I don't have to put that in parentheses, and then I get the bottom. Okay, so my denominators are the same. So now I can look and combine this whole top together. So when I do that, I end up getting these combined and have 4x squared. Combine these and I get negative 1x. And then I combine this and this, 8 minus 4. And that is going to be over okay, and that is where I ending up. That's as simple as I can go. I could simplify that, but what happens when I simplify that is it gives me nothing to cancel with this. So when you are at that point where it doesn't matter if you cancel or not, or if you're not going to be able to cancel, why go through the work of simplifying it? And as you get going with this, you'll just be able to look at that and determine, oh, yeah, not gonna happen. Okay, the B part of that is the exact same thing, only there's a minus sign there. So you're to factor it, just like we did up here. You know, we simplified this by putting it into factors, you know, this trinomial right here. And we then changed the numerator, and once we got common denominators, added the numerator. And in this particular one, in B, when you get to this point here, you'll be able to factor this numerator and cancel. So then you'll go ahead and factor it so that you can cancel with what's on the bottom and end up with quite a more simple solution there.
So it hasn't been going too good.
So the last part of this lesson is page 35, complex rational expressions. Really all a complex rational expression is fractions over fractions. So if we have 1 over a plus 1 over b, and that's over, big thicker line there, 1 over a cubed plus 1 over b cubed. Okay, that becomes a complex rational expression because there's fractions here and here within this fraction. Alright, so I made that line here thicker because what we're going to do is we're going to add these two up. We're going to add these two up so that we only have one division sign, because here we have a division sign here and then one here. We're going to find common denominators. We're going to have one division sign here, one division sign here, and then we can take this bottom, flip it over, multiply it, and life becomes so much easier. Alright, so 1a, or 1 over a plus 1 over b, and I shouldn't have to do the work in order to find that, so I'm not going to. That's just stuff that you should already remember. We'll give you b plus a over ab. Okay, so there's your top number. Once we combine those terms, now we've only got one division sign or one fractional line instead of two like we did here. Okay, let's keep going. On the bottom, when we take 1 over a cubed plus 1 over b cubed, we end up getting let's see, b cubed plus a cubed over a cubed b cubed. Okay, and that's just because I looked at this here and said, alright, I'm missing one over here, so I'm going to put a b cubed here and a b cubed here. And then I look at this here and say, what am I missing that I have over there? And it's an a cubed, so I've got an a cubed over an a cubed. Okay, so now I have a b cubed plus a cubed when I bring those two together, because now I have a common denominator of a cubed, b cubed, which is there, and I can bring these two together. So b cubed plus a cubed. Okay, so now I only have one fraction there and one fraction there. So I'm going to take this and turn it upside down. So I end up with this times a cubed b cubed over b cubed plus a cubed. So this is gone now. Now I'm multiplying it. So this is what I have left. And when I do that, I can start canceling. So I've got an a there. I can cancel with one of my a's there, and that'll turn into an a squared. This b will cancel, and that'll turn into a b squared. So I'll end up with a squared b squared times b plus a over, oops, I got rid of that ab right here, so I don't even show that. Let me get rid of that. Okay, so I've got b cubed plus a cubed left. Now this is the sum of two cubes. And if you remember from intermediate algebra, you get two parentheses. You get one with two terms, and then you get one with three terms. And this third one here is that, or this term here is that. The term that goes in front of that is a b plus a. Okay, that's just memorizing. It's just remembering when you have the sum of two cubes, it equals that formula. So that being the case, I can cancel that with that, and I'm left then, let me circle with blue, that over that, and I'm done. Okay? The example in the book does not do it the way that I just did it. It does it a completely different way. So if you look on bottom of page 135 and you try to follow their train of thought with the way I'm thinking, you'll find out that it's nothing alike because I do things quite a bit different. But now that I look at page 36, it looks like they do a different method, and that looks very similar to the way I just did. So anyway, that's the review section number 5 for college algebra.